Stardate 2025-1105, and today we have a Star Trek Voyager light gun game that had been sitting on the shelf for years, and it needs its system scanned and maybe even its program hacked before we can send it back out for its next voyage. Let's get started. This video is going to be a little bit different from a normal repair video because although I will be performing a little bit of a repair at the end for a missing security button, I mostly wanted to document this to show you how to bring up a Star Trek Voyager board that hasn't been on for years and lost its CMOS settings and all that. So let's take a look at the board. All right, so the board comes on this big old piece of metal here. You can see STV, and it is an ATX motherboard. The actual type is a K7T Turbo 2. But this is a standard computer motherboard. You can see it's got a couple PCI slots here. It's got an AGP slot, 2 IDE, floppy drive, RAM. The CPU I didn't bother to take off the board here, but it's about 1 gigahertz. So just like a basic computer, what we need to turn this on will be a hard drive and some RAM. So starting with the RAM, this is the original one. So this is 128 megabytes. PC133 SD RAM. I did try another one that I had sitting around that was the same amount of RAM and it worked fine. So this part doesn't seem to be anything special. I'm going to stick with the original and it seems to work in any slot. I'm going to start with this inner one here. Next will be our hard drive, and the original here is a 20 gigabyte Maxter drive, regular IDE, and it's set for master with the jumper at the back here. Now, one of the things that will be often broken about a Star Trek Voyager is the hard drive, so let's pretend this one is not working and we need to write a new one. How do we do that? I'm going to be using this little IDE USB adapter, so this fits on here, and power goes in here. And then I've got a power adapter input here and a USB to my computer here, so I'm going to use this to write it. If you have an old enough computer, you can actually just attach this to your IDE cable, but most likely you're going to be using a USB adapter of some sort. I'm also quite confident you could use a compact flash card and IDE adapter. I didn't happen to have any that were over 16 gigabyte and the image is 20 gigabyte, so I didn't want to try that. But if you have a 32 gigabyte or something bigger, then you probably can use one of these in place. We are going to be using MAME to rewrite this hard drive image. Obviously, you'll have to find the image on your own, but it is out there. So we have to be in an administrator command prompt. And the first thing we're going to do is use a program called diskpart. This is built into Windows. We're going to type list disk. So we will select disk 2, and we will use the command clean. As far as I understand, this destroys all the partition tables, etc. on the disk and prepares it for a raw image write. Okay, we can exit. Now in your MAME directory, type in chdman to see what that does. We see that that is the compressed hunks of data manager, which is the file format that MAME uses for hard drives. So in our case, we're going to use chdman extract HD and direct the hard drive image directly to the physical disk that's attached by the USB adapter. Our command is going to be chdman extract HD -I for input file, and I have mine over here. Then our output file is going to be, this is a bit difficult, //./ physical drive, and then the number we had before, so we had number 2. Sometimes this works as is, but adding a -F seems to have better reliability. That's the force flag. Not sure exactly what it does, but it works well. And this will take quite a long time to complete, maybe 20 minutes for a 20 gigabyte disk. So we'll check back when it's done. Now, unfortunately, this is actually normal to end up with an error that says error writing to file, check disk space, fatal error occurred 1. But as long as you can see it get to 100%, like it gets up to 99.6, 99.8, it will be fine. I think what happened is when these images were created, they maybe were slightly larger than the actual hard drive, or maybe there's variation among hard drives for actual number of bytes available. If you use a larger drive, like say a 40 gig drive or say a 32 gig compact flash, you won't get this error. The other part of this game is this board here, which is called the MegaJAMMA, and it plugs into the parallel port here and provides the JAMMA interface that would go to the rest of the cabinet, as well as the interface for the 2 guns. We'll talk a lot more about this a little bit later on, but for now we're going to focus on the main motherboard, since we can actually make some progress without having this in here at all. This is the video card. It is a GeForce 2 MX32. It's a pretty common video card. Like if this goes bad, you could just buy another one. It's AGP interface. that just slots in there and is actually held in place to the game port, which is unused in this. I have actually found that the connection between the video card and the motherboard can be flaky and will cause it not to boot. And if we come across that, I'll let you hear the error code, the beeps that come out of this thing. This motherboard does have an onboard speaker, so if it has error beeps, you'll hear them without having any other speakers connected. Next thing we're going to need is a power supply, and honestly, just any old off-the-shelf ATX power supply is going to do. This is just a cheap 450 watt. Doesn't seem to require very much because we don't have a special GPU or anything on this. So at minimum, we're going to have to connect the main power, and you'll have to find a CPU power that will connect. Only the correct one will fit with the pin layout. Okay, that one's good. So let's get our freshly written hard drive mounted. Now we're going to connect our IDE cable. Doesn't really matter that it's a blue end on this one, although it does need to be an 80 pin cable, so it should be nice skinny cables, not the older thick ones. It does have to go in IDE 1, which is the blue port here. If you try to put it in IDE 2, the white one, you will get an error as you load it up. I'm going to mount it the other way so that the cable just goes around the back side here. Right, let's connect this up. That goes into IDE 1, and then we will connect the other end of the cable to the IDE port. So, and we will need to connect one of the old style 4-pin power connectors to this hard drive, which even seems like most new power supplies still have a couple of those on board. You'll need 2 for this actually. Now, we're missing a battery. I took this out on purpose because when you come across a motherboard this old, the battery will likely be dead or missing. So it's just a regular old 2032, so let's stick that in. I'm going to capture the video directly from the video card to start, so I'm going to plug this right into the video card, plug in power to my power supply, and when I turn on the power supply, nothing. Of course, this is expected because most motherboards, as you know, don't tend to turn on with the power supply. You've got to hit a power button, but of course there is no power button attached to this. So we're going to have to actually jump the pins with a piece of metal or with a little jumper. But then we're going to change the BIOS to automatically turn on when power is applied. So we're going to zoom into this header at the back here. So we can see at the back here, the power connection, these 2 pins here, 1 and 2, just beyond this corner here, say power switch. So with the power turned on, we can just jump these little pins right here, and you'll hear the board spring to life. And there, we got a little boot screen. Next thing I'm going to do is hook up a keyboard. Got this nice old IBM Model M, and plug it into the keyboard PS2 port, which is the purple one. This motherboard does actually have some USB ports, but I found that the support is not good for it. It actually makes some things hang. Turn on the main power supply, and I'm going to jump those pins again to get the computer started up. There it goes. And I'm going to be ready on the delete key to get into the BIOS. Alright, so the first thing we want to do for sure is go into power management and go down to state after power failure and turn this to on. This way, every time you just turn on the power supply, or in the case of the arcade machine, turn on the whole machine, it will just start up right away. Let's save and exit and see how far we get. Memory test has passed. It's detected the hard drive. Floppy disk fail. Okay, we can fix that. Let's go back into the setup. We'll go into standard CMOS features, and we will change halt on. No errors, just always start up. Try again. Everything's looking good so far. Okay, we have a Linux menu. It's going to start itself up. Lots of Linux gibberish. Okay, we're getting boot to a Linux desktop, and we're stuck here. Interesting note that the Linux desktop is in 24 kilohertz mode, which is a medium resolution monitor, which is lower than a high resolution monitor that we would normally use for VGA. So this game actually works in either 24 kilohertz or 15 kilohertz, 15 being standard arcade resolution, for the kit version, and the dedicated cockpit version only works at 24 kilohertz. It seems to just be a matter of which hard drive image you have. I know the one I have on the hard drive right now is the kit version, so it can be switched. but the switch is on the MegaJAMMA board, which we don't have hooked up yet. That also means that when you turn this on in a real game and it boots up in VGA mode, which is 31 kilohertz, it's just going to look all crazy on the screen for a little while, and you just have to put up with that if your screen isn't a tri-res one. So this is a pretty common place to get stuck in when you're trying to get one of these games working again. You get to Linux desktop and not know what to do next. The game should actually boot itself, and at this point it seems the problem is going to be in the parallel port settings. The motherboard defaults to a setting called ECP, and the game actually needs EPP. So back in the BIOS now, we're going to go to Integrated Peripherals, and we are going to go down here to onboard parallel port. So the port and the IRQ are fine, 378, IRQ7. That's the same IRQ that we see on the Z80 chips, by the way. There's just a lot more of them on an X86 or an X64 chip. Parallel mode, we have options between normal, EPP, ECP, or ECP/EPP. So we must change it from normal to EPP mode. I do not know exactly what the difference is, but that's what we're going to use. Oh, so that's interesting. That looked a little bit different, and I can actually see that it's booted into 15 kilohertz mode, not 24 kilohertz mode. So when the parallel port was in the wrong mode, couldn't start the game, and defaulted to 24 kilohertz. When it can read the parallel port, but the MegaJAMMA board is not connected, seems to default to the 15 kilohertz mode. I'm going to take a minute to try and center the image a bit better. Now the game has booted, we see a rather obvious problem, which is that the giant not authorized banner is up over the screen, preventing the game from really being played. I did figure out that the keyboard controls do work in here, so I can actually put credits in, if you saw that there, credits 2, and I can actually start it. I mean, I can't do very much because I can't use the guns or anything, but the game will play behind this big banner, which will become important a little bit later. Now, before we tackle the security problem, let's at least get the MegaJAMMA board hooked up and test out the controls. So this simply goes on here, and while we're here, let's plug in an audio cable from the green jack there to the audio input on the MegaJAMMA board. And I'm going to hook up my JAMMA adapter here. I am going to actually remove the power. I don't want voltage going, in the wrong direction up to my power supply. Since everything is being powered from this direction, don't want power from this direction as well. Speaking of that, we should also plug power into the MegaJAMMA board, which comes from another 4-pin hard drive-like power socket. And one very interesting note, I figured out eventually, this was really confusing to me. In order for the controls to work, you have to use a VGA cable that goes from the video card into this, and then get the video out from the JAMMA connector. Now, of course, you could run a splitter first or something like that, but it is absolutely required to use this interconnect because the controls won't work without it. This one stumped me for a bit when I was doing some tests. I couldn't get the controls going, but I had just had this connected the whole time. My theory is that the control circuitry here actually uses either the vertical or horizontal sync pulse to decide when to actually pull the controls and send them to the board. They've also made this male connector, so a standard VGA cable is already male on both ends, so we have to use this gender changer to plug it in. And then I'm going to plug this in. All right, now I'm going to turn on my test switch, and let's start her up again. All right, good. So now we're in the test mode, so we know that the input controls are working. Since the test switch is on the outside of the JAMMA connector, it made its way in. So you navigate these menus just with Start 1 and Start 2. Oh, I hit exit. Okay, so Start 1 will go through. I can take a look at, let's go to game options first. Here we have our basic difficulty, lives, and game speed. That's kind of neat. Coin options, we'll skip that. Gun test we'll do in a minute. So we'll look at inputs really quickly here. So yeah, there's Start 1. Coin 1, coin 2. I don't have the gun. Actually, let's plug a gun in. I got one here. Got a regular old HAP gun. Plug that into gun 1 here. Okay, so that's showing trigger 1. It's not gonna do any calibration because I don't have the CRT hooked up, but that's trigger 1. I'm gonna move it over to the second one. Trig 2. Great. Okay, I'll quickly hook up to a CRT so we can test the gun calibration. I'm on my little CRT here. Let's start the gun test and verify fire guns at screen. Make sure we get good crosshairs, and we do. So no problem there. Move this over to the second one. USB player 2, all good. All right, guns are great. Yeah, so I can hear the sound is working, but it sounds like it's unamplified. So I'm not sure what the MegaJAMMA is doing. I actually think this could be to do with my JAMMA adapter, with the way the sound is attenuated there. So I'm not going to worry about that right now. I'm going to check it in the real machine later, and hopefully it'll be full volume there. This game is in stereo, and my JAMMA adapter is not really made for stereo, so. Alright, so now we get to the fun part of the video, which is we got to get by this not authorized screen. On the MegaJAMMA, there is this spot that looks like it's for a watch battery. It's actually for a security device called an I button. I had put this board on the shelf a couple years ago because it didn't have an I button and there was no known way to get around it at the time. And recently on the Arcade Museum forum, someone else brought up the fact that we hadn't gotten around the security, and a member named MegaTouch Mike piped up and said, I'm pretty familiar with these I buttons, I guess with the MegaTouch games. He said, let me look at the hard drive image, I bet I can patch out the security. And about 24 hours later, he sent me a patch. I tried the patch and it worked. No not authorized screen with no I button in place at all. Look for a link in the description below for his blog to see exactly how he patched it out. I read his blog and the first step was so simple I can't believe I didn't think of it, and after that I thought I bet I can patch it out myself. So I'm going to take a slightly different path than he took, using some different tools to arrive at almost the same conclusion. So we need a game plan. The game plan here is to copy the game executable out of the system into a Windows computer. I'm going to use the program Ghidra, which is the NSA authored decompilation tool to decompile the program as best I can. I'm going to search for that not authorized word in the program, see how it's triggered, and see if I can skip it. So we have some fun we can do here right in the game. So if I press F12 on the keyboard, I get a menu for the operating system. So I can go down to X term here, which is going to be a terminal. I can actually run a terminal and like poke around in the system. I'm going to use top to see what programs are running right now. And I can see the top program is called Trek, being run by the user Rocky. Kind of funny, I don't know if someone named Rocky built this or what. So the program ID for Trek is 646. Apparently I can use read link F proc 646 exe, and it will tell me where it's coming from. I was looking around and I remembered that on older Linux distributions included some games, and I had one that was called Trek, so I think I can actually play this text-based Star Trek game inside the Star Trek Voyager game. Okay, 11 Klingons, 3-star bases. I cannot figure out what's going on. This appears to be a text-based strategy Star Trek game with Klingons, but let's get back to our task at hand. So we now know that Trek is the file name and Rocky is the user. We are a bit limited with what we can do with this version of Linux because it's mounted as read-only, and I was not able to remount it as read-write, so I wasn't able to figure out any way to get files off of this in this version of Linux. I decided to burn a version of Linux I've used many times to rescue PCs called Damn Small Linux, DSL, onto this CF card. So I'm going to actually run this as the primary hard drive with the Star Trek Voyager hard drive as the secondary and see if I can get the file off that way. So I'm going to move the Star Trek hard drive to the other IDE, which will place it further down the line. And I'm going to place this DSL Linux from the CF card in the first one. Grab power here for the CF card. I did try again using USB. I actually tried even updating the BIOS on this, which apparently had better USB features, but I was not able to get this same Linux to run from any USB sticks. So the CF card to IDE adapter will have to do. All right, so DSL. I'm actually going to boot to DSL 2, which gets me to just a terminal. No need for a desktop here. So fdisk L will show me what drives I have. So the first drive, HDC, at the top, you can see there says 20.5 gigs, so it's going to be that one. I don't know which of those 4 partitions is going to contain the file, but let's start with HDC 1. Now that I have HDC 1 mounted, I can do find mount STV name Trek So we have some matches here. Funny enough, there seems to be 2 different games called Trek that are like part of the standard Linux distribution for a long time. One of them's a quiz game, one of them appears to be like a little simulation game, both text-based. But the one we want is definitely the one in Rocky's directory called Trek under the directory STV. C-ROM. Okay, now I can copy it. Okay, and there it is, Trek. Sync. Okay, so after all that, we have the Trek executable file on the CF card. I can now move it over to Windows, and I can use the disassembler to try and figure out the security. And just a reminder that you would have to have this MegaJAMMA board with or without the I button to run this game anyway, so I don't think it's too naughty to describe how to bypass the security in this particular case. There is one other game that uses the MegaJAMMA system, and it's Police Trainer 2. And from what I found, the same security I button works in either board. So they weren't even using that part of the security to protect against switching between games on this MegaJAMMA system. I have started a new project in Ghidra, and I'm going to import the Trek file that we took off of the hard drive. I'm going to leave it as an ELF, language x86, destination folder, program name, all good. Gives us some information here. Looks like the original compiler used was in 2001. And we'll right click and open a default tool, which opens the code browser. Trek has not been analyzed. Yes. Sure. Let's do search memory for a string called not authorized. Search. Oh, found it right there. Okay. There it is in the code. So there it is actually pushing it to the screen, and yeah, we do appear to be in a function called draw obnoxious message. So this is surprising to me. I didn't realize that when you make these kind of function names, they stay in the compiled binary. I'm sure there's a way to turn that off, but they left it on. So that's what we have. So if we look on the right side here, we can see the pseudo code here. So this function called draw obnoxious message actually starts a 2D mode, draws that big red box, and then puts the text on the screen, and that's what it does. So from here we want to figure out what actually causes this to launch. So let's try references to draw obnoxious messages. Here's a call here. On the right here we have if the frame count is more than 3B and IBOC equals 0, draw obnoxious message. Okay, so that's why we don't see it for the first few frames when the program starts, and then it shows up because it's got a couple frames. I think 3B is 59, so 59 frames. So for the first second, don't draw it. One of the things that Megatouch Mike pointed out was that IBOC probably means I button OK. So if IBOC equals 0 and the frame count is more than 59, draw obnoxious message. Cool. Next thing we should do is take a look at this IBOK. Find references to IBOK. Only a couple here. Okay, let's see what they are. First one, that looks like all that does is actually return the status of IBOK, so that's probably not what we need right now. Down here, this is what we just looked at. And here's the only other reference here, which sets IBOK to the output of verify IB. Okay, that sounds good. So if I click on verify IB, I can go to that function. And this is where it is actually communicating with the I button. It's all this stuff here. And I believe Megatouch Mike's solution was to just always return a 1 rather than the variable. So it doesn't really matter what it does, it just returns 1 all the time. His solution definitely makes sense. But because I noticed that the obnoxious message is the only time that this thing is actually used, I thought it would be fun to just do something to stop the message from being shown. So let's go back to show obnoxious message. So this is where draw obnoxious message was called. And all I want to do is change the comparison here so that it never does. I do have a few limitations here. I really can't change the length of this whole command, this compare command here. I could shorten it to something else and then put in some no operations after it. But I thought it would be cool if I could actually just patch a single byte. And my idea was this IBOK equal to 0. If I just change this to IBOK equals 2, then this will never launch because IBOK can only actually be 0 and 1. So all I need to do is change this 0, 0 right here to 0, 2. And that should actually bypass the message completely. So I'm going to need the byte source offset. So that is 49839. And I need to add 1, 2, 3, 4, 5, 6 bytes to that, plus 6. The 4983F is our address. Let's change this last byte from 00 to 02 and save it. Now I'll copy this back to the CF card containing the second copy of Linux, and we'll reboot on the computer to copy it over to the main hard drive. I figured out that the Trek file is actually a symlink to trek.e4. And I noticed there's all these other ones in here, like trek.010d, d2, e1, e3, e4, and f. So I actually wonder if those are different builds. Maybe sometime we can check into those and see if there's any differences. But anyway, trek.e4 is the current one, so I'm going to make a backup of it, just in case. So now what I can do is copy CD-ROM Trek to trek.e4 in this directory. Overwrite, yes. Okay, and that's been written. Now we can get rid of the CF card and put the main hard drive back into slot 1. All right, so we're at the point now where it should actually work. We should not get the not authorized message if my plan worked right. So this should really be it. The hard drive is now patched. It should load the same file, but with the patched code. It shouldn't load that not authorized screen after it checks for the I button. We are at the desktop. Game is loading. And that's it. No message. Coins, yeah. All right. I temporarily rewired my jig here, and the sound is working great, coming nice and clear. I got a splitter for my video, so I've got the capture as well as the CRT here, so let's see if we can get everything working. Guess I don't know if the light gun will work with the splitter, but let's find out.
Welcome aboard.
Wish I had 3D printed like a phaser. Yep, working good. Oh no. So recapping what we did today, we got this computer set up as if it were a normal computer first, made some BIOS changes in order to get the MegaJAMMA board to read properly. Then we copied the main executable file off of the hard drive to the computer where we disassembled it, found where the obnoxious message was located, and changed the logic so it couldn't be triggered, put it back on the original hard drive, and everything is working great. This seems like a pretty fun game. I will definitely try it in my big light gun cabinet at some point, but the game is all fixed. That's all for now, and I'll see you next time.